So in part B, we are given f of minus 3 can be written as this function. So what we are told is that f of minus 3 is equal to the sum from n equals 1 to infinity of n plus 1 over n squared multiplied with minus 1 half to the power of n. Now what we see is that the sign of the terms in the series is alternating, meaning it goes from plus, minus, plus, minus, plus, minus. It is also a continuously decreasing function, and its limit, so the terms of the limit are approaching 0. Therefore, these series are called Leibniz series. These are always converging for all x. And so the conditions again for a Leibniz series is that it has alternating terms. It goes minus, plus, minus, minus, plus, minus, plus, minus, plus, and the terms of the series must all go to 0. So the limit of this has to go to 0. In that case, we can say that an error, so if we write the sum from n equals 1 to 3 of n plus 1 over n squared times minus 1 half to the n, this will be equal to minus 125 over 144. And this approximation has an error that is at most the next term's value. So when n equals 4. So the error of this is at most the n equals 4 terms. So that will be 4 plus 1 over 4 squared. And then minus a half to the power of 4. This will be equal to 5 over 256. And well, this here is smaller than 150, so we can give a approximation of it with something that is larger. So we made the denominator smaller, so this is overall larger. So this here is 150, and therefore we can show that this function, so up until 3, so these first 3 terms sum, has an error of at most 150, because the error is at most the next term in the sequence. And therefore, what we can say is that f of minus 3 minus s of 3, so the approximation is at most having an error of 1 over 50.